Good afternoon and welcome. Today we are going to be doing a ARP spoofing attack, a DNS spoofing attack, and in a lot of ways we call this a DNS poisoning or even an ARP poisoning attack. We're going to take into consideration all the great things, the implicit trust in which networks are built upon, and we're going to go against those in our virtual environment. As always, I have to put out that little delimiter in there. What we're doing inside of a virtual environment is completely legal because it's in our environment, right? We created this sandbox environment for ourselves. We're using virtual machines. We own those machines, so we're giving ourselves permission to perform those attacks against ourselves. It'd be illegal is if you went to a local Starbucks or you went to a open network, or you even inside your parents' network and they didn't give you permission, then you could be held liable under the Computer Fraud and Abuse Act. So make sure that you understand the confines in which we're operating this lab in. If you go outside those confines, you can face some pretty hefty fines and jail time. So I want to warn you, once again, we only do these little labs that I'm providing you inside of a virtual environment, inside of a sandboxed environment in which you own the assets. With that said, let's get started. All right, so this lab's going to be a little bit different. We're going to do address resolution protocol poisoning, or ARP poisoning, and that has to be done inside an environment that utilizes DHCP. Now, if you've gone through my other videos, you probably realize that my home lab is usually set up with a static IP address as opposed to a dynamic IP address, so it really wouldn't work in that environment. So in this case, we've decided to use Kali Linux using DHCP, and then I set up a secondary Windows system utilizing DHCP as well, so it's outside of our normal lab environment. So let's just get into it and then we'll go from there. So you can see here's my Windows system, and I'm going to go into the command line, the CLI. To get there, I type in CMD under this little point right here, just CMD, and that'll get me to the command prompt, and that's what I'm looking for. And we're going to take advantage of ARP, Address Resolution Protocol. So first, I want to point out what ARP is. So we're going to do an ARP-A, and this will give me all the devices on my current network that are utilizing that same atmosphere. And I can do the same thing for my Linux as well. If I go to terminal over here, I'm going to do ARP-A. Let me blow this up a little bit for you. And you can see this machine is only showing itself. It's not even showing any other... It's not even showing itself, to be honest. It's just showing a .3. So we'll do a quick nmap. I'm going to do a switch SN and then 10.0.2.0. Numlock's not working. 10.0.2.0/24. This is going to be a ping sweep across the board for that network, which will pretty much hit all the devices that are currently on this network. And obviously I screwed up a typo right there. Let me fix that. 10.0.2. There we go. .0/24. That'll ping all the devices on the network, which will update our ARP table. The Windows machine, let's bring that sucker back up over here. You can see it's already showing 10.2.33, which is my Linux box. And you can see here that my nmap is only picking up 10.0.2.1, so it's not even seeing those other devices yet. Let me do an ARP-A. Here we go. So we got 32, 29, 1, 3, and 2. 29 is my firewall, which I have working right now. And where is my Windows box? Let's see this. IP config. We're operating on 32. So it's showing 32 right here, which is where we want to. All right. So I want you to pay attention to this right here. Under the Windows box, I want to kind of highlight this right here. We're under 33. If you look at this physical address, that MAC address right there, we can see it's on 08002705BE-02. That MAC address is where our Linux box is. And then you can see our 2.1, that's our gateway, right? That's our default gateway. And VirtualBox uses just like a regular system. This would be your router or your exit point out of the network. This is our default gateway. And you can see that physical address right here, that MAC address, 52.54.00.12.35.00. So what we're going to do is we're going to trick the Windows machine into diverting all of its traffic through the Kali box in order to get outside the network. So let me throw this up on Paint real quick and show you what I'm talking about. All right, let's kind of dive into this. In a normal network, right, we've got our router right here. This is our router. We have our internet over here. I know, my paint program just doesn't work well. My drawing skills suck, right? I get it. It's okay. This is going to be our 10.0.2.1 right here. This is our default gateway. This is our router. This is where everything exits out and goes to the internet over this way. On this side, we have two boxes. We have our Windows machine right here. We're at 10.0.2. What are we at for Windows? I think it's 31. Am I mistaken? I'm probably wrong with that. Let's find out. Oops. Let me throw this over here. Windows box is on 32. So 32, and that's Windows. And then our Kali box right here, that's on 10.0.2. What do we got? Is that one 33? I'm really bad at addresses. What can I say? I need to work on it. That's no big deal. So that one is on 33. So it is on 33. Okay. So we're on 33 right here. Now what we're going to do in a normal network, right? We have an intrinsic trust system. So the Windows machine is going through the router to get to the internet, and our Kali box is going through the router to get to the internet. What we want to happen is we want the Windows machine to go through our Kali box to get to the internet, which will allow us, our Kali box, to kind of do a man-in-the-middle attack and allow us to do some other weird and freaky things. And that's where ARP poisoning comes in. The reason it won't work in my virtual environment, in my normal home lab setup, where we're using the firewall, we're using all those other things, is because this Windows box is usually set up as a static IP. And with a static IP, it knows that the default gateway is 10.0.2.1. It knows the MAC address. It's not going to change it, right? So that's kind of the way to get out of this. But if you're ever at like a Starbucks, an open Wi-Fi system, something like that, you'll hear us in cybersecurity constantly tell you, do not get on open Wi-Fi systems. And this is one of the reasons why. There's other reasons as well, right? I could do a rogue access point, which kind of does something similar. But this ARP poisoning attack is just one of many attacks that we can do. So let's jump into this. Let's kind of go through it a little bit. We're going to use a program called Bettercap. And the first thing we need to do is install it. So I'm going to do a sudo apt-get install Bettercap, B-E-T-T-E-R-C-A-P. We're going to install that. Shouldn't take too long. Okay, so that one's installed. So in order to initialize it, we're just going to type in Bettercap, like so. And you'll see that it's giving me permission denied. We need to be in root, so I'm going to go ahead and go up to the very top. I'm going to click on this root terminal emulator, type in that trusty password. It's going to give me access to the root terminal. Let me blow this up a little bit for you. And now if I type in Bettercap, I shouldn't get permission denied. And you can see here that it's providing me our current IP addresses, right? It's saying, hey, we're on the 10.0.2 network with a /24. That's at like last CIDR, which is going to be 0 to 255. So 10.0.2.0 through 255. And we're currently on 2.33 for our current system. Like any other normal Linux system, if I type in help, you'll see that it's providing me this this kind of information here, right? It's telling me, hey, the proxy isn't on, it's not running. ARP spoof isn't on, C2, our caplets, so on and so forth. The only thing that's really running right now is our events.stream, which is fine. Now, if I wanted to know about any of these, let's say that I wanted to know more about Wi-Fi, I could do help and then type Wi-Fi. It's going to provide me kind of associated commands associated with it. It's going to tell me how to do all this fun stuff. In this case, we're going to do help.netprobe, so help.net.probe. And if I see over here, you can say netprobe's not running, and I could turn it on or I could turn it off depending on what's going on. In this case, I'm going to type in net.probe, and then I'm going to type in on, just like so. And if I type in help again, you'll see that now netprobe and netrecon are running. Now recon is going to basically track and look for devices and other computers that are currently on the system, and the probe is searching for those little devices. So they kind of do a lot of the same thing. NetProbe is more about probing the IP addresses on the same network, where NetRecon is more about grabbing those if I was attached to several different networks at the same time, right? So they are attached. They're very, very similar in the aspect of it. Okay, next one we're going to do is a net.show. If I do a net show, it's going to show me all the current devices on my network. You can see here that I got 10.33. This is the computer that I'm currently running on. We can see 2.1, that's our gateway, 2.3, and all these other devices. It's just kind of throwing us out there and it's saying, hey, how much information has been sent, how much has been received, and when we last saw these devices. So obviously we know that 2.29 is our current firewall, which we're not really worried about, and 10.2.32 is our Windows system that we have on the same network. So we want to kind of start a spoof, right? So if we type in help again, and if we scroll up, we can see this ARP spoof right here, and it's not running. So we're going to do a help ARP.spoof, and we can see here that we can do ARP spoof on, we can do an ARP ban, we turn it off, and we turn the ban off. So where we really need to begin is just doing specific commands, right? So if we look at the parameters, we can see arp.spoof.full-duplex. If true, both the targets and the gateway will be attacked, which means I'm hitting both the default gateway, but I'm also hitting the Windows machine at the same time. And that's really what we want to do. So we're going to do set arp.spoof.full-duplex, and you can see that right there, that full duplex, and no spaces. I don't know why I do spaces. Full duplex. And then we're going to type in true, because it tells us if true. We see on over here, we see true over here. Okay? So we're going to turn that on, and if we do help again, you can see that ARP spoof is still not running because we've only set it up for full duplex. We haven't turned it on yet. Okay? So let's run this command. We're going to do set arp.spoof.targets. And let's go back over here. Let me do help arp.spoof first, and we can see here, here's our targets, right? It tells us arp.spoof targets, comma separated for list IP addresses, so very easy tool. So I'm going to do set arp.spoof.targets, and I have to define what I want to attack. Well, I want to hit the router, so that's 10.0.2.1, and then it says right here, put a list of IP addresses, MAC aliases, so on and so forth, separated by a comma. So we're going to hit both ways. Since we're on full duplex, we can hit both the router and the Windows machine. And then we're going to do 10.0.2.31, I believe was what our Windows was at. Let me double check on that one. And we can see here our Windows is at 32. So let me change that to 32. And then we'll set that. And now we're ready to actually perform the attack against the target. Okay? So we're going to start real quick. We're going to do arp.spoof and then on. This turns it on, and if I do a help, we can see now that we're running that ARP spoof right there. Okay? So I'm going to do a net.show. Let's go back into our Windows system and see what's going on over there. So if I go back into Windows and we do an arp-a right here, I want you to see what's going on here, right? Here's our 10.0233. Right? We can see the MAC address 08002705BE-02, and now you can see the gateway also has that same MAC address. So we have successfully spoofed the target machine with the router. And if I were to plug into the router, if this was a normal router, our 10.33 would mirror the same MAC address as our 32, which is our Windows. And so that ARP spoof is really going on right now. All right, so the next command we're going to run is a net sniff. So net.sniff. And you can see that our net sniff is starting to detect that information from our Windows 10. So let's go back into our Windows 10 here. Let's go on to, I'm going to use, I used Google last time. I'm going to use Microsoft Edge this time. We're going to just go to a plain text website, not something that's not HTTPS, right? So we're going to do http://. I'm going to do unicorn items. unicornitems.com. This is an HTTP site. No thanks. And let's kind of see what's going on over here, right? I've got unicorn items, and you can see that we're doing Google Let Manager. We can see all this Google Analytics, okay? But let's see what's going on up here. If I come up a little bit, I can see that my Kali box detected my Windows machine accessing the site unicornitems.com. We can see that it has access control. Let's log in. Let's go back into that Windows machine. And I'm going to say don't ask again. And let's do my account. Now I don't have an account with them. It's not a big deal. All right, but let's just type in something. I'm going to do chet@hotmail.com. And then I'm just going to do a password 123456. I'm going to log in. I'm not going to save it. Well, I guess I did save it. Let's scroll down a little bit and see what's going on now with this. All right, so this is where we try to access the site. I can see unicornitems.com. We can see the account. Now this, because it's going through the Kali box to get to the internet, you can start to see the information that's being passed down, right? We can see the refer, the agent. I should be able to see the actual script, in which case we tried to log into the website. So we see the cookie here, which we could utilize in an attack later on the road. Let's see, what else do we got here? Keep alive, keep alive. Here we go. You can see right here, a little bit ways down the road, that the user typed into this website, chat@hotmail.com, with the password of 123456. And it's printed out there in red. Because we're conducting a man-in-the-middle attack, because the device is going through our Kali box to get to the internet, we're able to pick up all that information. All right? So kind of cool on that aspect of it. You can see now we're going to actually do a little bit different, right? We're going to do a, I don't know, let's do LinkedIn. So LinkedIn.com. Now LinkedIn's running HTTPS here. I'm going to go ahead and try to sign in. Let's go back to our Windows box over here, or excuse me, our Kali real quick. Right? But it's not really detecting that we hit LinkedIn like it did before, right? And that's because we're on an HTTPS site. So let's try and hit this. I'm going to do chat@hotmail.com, and again we'll do that password of 123456. We'll go ahead and hit that sign in. I'm going to hit never. It's going to try and detect it. Let's go back into our system here, and you can kind of see that it's not giving us near as much information as it did when we went to an uncalculated site, right? We can see Bing, but we're not seeing LinkedIn hit in at all. We're not seeing the username, we're not seeing the password, because it's all encrypted. It's all using that transport layer security, that SSL, to hide that information from us, okay? We can see that it's hitting this DNS, right? But again, it's not telling us where we're going. It's not telling us anything pertinent because we're doing an HTTPS, right? If I scroll down a little bit more, we can see here it's saying activated. Before, it showed us that we were going to unicornitems.com. Now it's not telling us anything. It's literally pretty much blank in every aspect, right? Let's see here. It's not telling us the name. It's giving us the weather for Microsoft. It's just not giving us anything. We just don't have anything like we did before. So the object at this point would be to get the attacker to downgrade their attack, right? If I was a malicious actor, I would want to take that LinkedIn, that HTTPS LinkedIn account, and I would want to downgrade it down to HTTP. However, a lot over the last decade, websites have been removing that capability, right? There used to be about a decade ago where you could take an HTTPS website and they had both an HTTPS and an HTTP, and if your browser didn't support HTTPS, then it provided that HTTPA as well, and as a man-in-the-middle attack, you could do a downgrade attack. So let's see what happens here when we try to do that, right? If I want to do HTTP, I left off the S, I can do / www.linkedin.com, and you can see here that it's going to kick it back over, and it made it HTTPS. And so a lot of those vendors, a lot of those websites now don't allow you to do a downgrade attack at all. So it's almost, it's an old style attack, not really prevalent today. And so my other option, if I was a malicious attacker, would be to clone this website and then do a DNS spoof and then force that traffic that would be going to LinkedIn to go onto my LinkedIn page on my web server. And that's where this type of attack is a little bit more advanced. It requires a little bit more to do, but you would have to be logged in as well as to do it. And that way you could force the user to thinking, as long as they didn't see that lock sign at the top or that HTTPS, you could technically fool the user into thinking they were really logging into LinkedIn. And then, of course, once they logged in, you just forward that information over to the legitimate website, and so they don't know anything's going wrong. And we're seeing that type of attack still for man-in-the-middle, but a little bit more complicated than what it used to be. All right, so I'm going to turn this off. We're going to do net.sniff, sniff off. I'm going to do a help. just to see what's going on still. We can see NetSniff is no longer running. We still have access to the ARP table. We still have access to that machine. But let's see if we can't do a little bit more. So just like before, we're going to type in help DNS.spoof. If I can type today, which I probably can't, spoof. We can see here that it's not running to turn it on and off. We can also do a DNS spoof address, IP address to map to domains too. So we're going to spoof a DNS, right? Now, DNS is a domain name service that basically translates an IP address into a common name. So in computer language, I'm not just going to Amazon.com. What my computer needs to know is the IP address for Amazon.com. And if I open up a new system right here, I can actually do a ping Amazon.com, and it's going to tell me that one of the IP addresses associated with Amazon.com is 54.239.28.85. I'm going to hit Control-C to stop that. And what I want to do is I want to take a domain and spoof it back into my IP address. And so what I'm going to actually do is I need to set up a server first off, right? So I'm going to do sudo service apache2 start, which is going to turn my, cannot type today, it's going to turn my Kali box into an actual web server, right? So I'm going to hit that password in there, and I can prove this if I go over to my Firefox over here, and I type in 127.0.0.1, you can see here that it's going to provide me with that I hacked you is in this awesome website that we used before, right? Because we set it up as index, so that's our landing page. What I want to do is I want to set the DNS to where if somebody accesses, say, Google on this website, they're actually not going to go to Google or Amazon, they're going to go to my website. Now, there's a couple conditions that have to rely on that, right? This would be an incredibly insecure system. They're going to depend upon that router for the DNS. If it's going through a specific DNS, then it's not going to work. So let's check our Windows system first. We're going to have to go into that command console. Let me right-click over here. We're going to open our network settings. We're going to check our Ethernet, change our adapter settings. I'm going to go to Ethernet number 4 over here, down to properties, and then IB4. And you can see that we have the DNS enabled right now to go to Google and through Cloudflare. I'm going to leave it like that for right now. We're just not going to touch it. Let's see what happens, though. Let's go back over here and see if this attack will work based on this, right? So let me go back over to here, to root Kali. Now we need to do the actual programming here to change it. So the command is going to be set dns.spoof.domains, right? And we're going to change it, I don't know, let's do Amazon.com, right? I mean, why not? So we'll do Amazon.com, and then we're going to do a semicolon, and then set dns.spoof.address, and we have to use our current address. We're going to do 10.0.2.33. That's going to send the address back into our system right here, okay? Now this is actually two different commands. That's what that semicolon's doing right there, okay? Hit that, and then I'm actually going to start the DNS, right? So I'm going to do set DNS, or not even set, sorry, DNS.spoof, and then space on. This is going to turn the DNS spoof on. I'm going to type in help, and you can see here that we are running a DNS spoof up here, and if you look back to this command, it is saying DNS spoof Amazon.com is supposed to go ours. So let's go to our Windows 10 system right here. It's still using the DNS for this, all right? I'm just going to type in Amazon.com, and let's see what happens. Okay, so there seems to be an issue. It's not able to click it. It's having a contradiction of terms. It's having some issues, right? So let's turn off this preferred. We're going to obtain the DNS server automatically. Let me click that. Press OK. Let's try this again. I'm going to go to DNS or Amazon.com. Now I am seeing that HTTPS. Let's do HTTP and then Amazon.com. And there you go. You can see that it hacked into it now. Okay. So I wanted to show you one last command before we call it a day. Let's do that help again. Help. I cannot type today. So help. We're still running that ARP spoof right here. We turn the DNS spoof off. So we're going to do an ARP ban. We're going to stop or do a denial of service attack using ARP. Okay. So we're going to do ARP. Let's do help first. So help ARP.spoof, just like so. and you can see that it's on currently. We need to turn it off, so I'm going to do arp.spoof off. So arp.spoof off, and let's do that help command again. I'm just going to press the up arrow twice, and you can see here that I can do an arp ban on, right? So let's do an arp.ban on, just like so. It's running. We're doing 2 targets. Again, we're checking that out. I'm going to do help again. And you can see now that our ARP spoof is running, but it's acting as an arp.spoof. Now, I'm going to go back to this Windows machine. We're going to hit a different website, a website we haven't hit yet. So we've done Amazon, we've done Google, we've done LinkedIn. Let's do Facebook. So facebook.com. And because we're doing a denial of service attack, and the traffic is going through ARP, but we're doing an ARP ban, it can't actually get any traffic, right? So it's obviously not hitting Facebook. Let's try something else. Let's try Google, just like so. And just to make matters just apparent to everybody, let's do unicorn items, unicornitems.com, and we'll hit this website as well. And you can see that they're waiting for a response. They are not going anywhere, and that's because that ARP spoof ban, or that ARP.ban, is on. It's preventing any type of a traffic. You can even see that our network 4 is saying it doesn't have access to the network because of that. All right. So let's go back into our Kali box one last time. We're going to do that ARP.ban off, like so. We'll do help. We scroll up. We don't have anything going on. And then let's go back to our Windows machine one last final time. Let's hit unicorn items. You can see that our internet is showing up now. We'll do Facebook, and we'll do Google, just like that. And you can see that these websites are now coming up, right? So this is a very dependable attack that only really works if you were to invade a network in which you're kind of on a guest, right? So very limited scope, but very powerful as well when you look at it from that perspective. So I hope you learned something from this. We did a little bit of DNS spoofing, a little bit of ARP spoofing, or ARP poisoning and DNS poisoning. As long as we have access to this system, or as long as we're inside the system with our Kali box, it'll work. Now, the scope of this attack is very, very limited, right? You have to be inside of a network. You have to have DHCP running. Your devices that are on the network have to not have a static IP address. They can't have DNS outside of the system. And so they're relying on a lot of Fs. But I want you to think about this from a cybersecurity standpoint. How many people actually go in and set up a static IP address and set up the DNS? How many people actually do that, right? And I want you to think about the same people that are using those open Wi-Fi systems, all right? As always, I want to encourage you to learn about this, learn from a cybersecurity standpoint, why it's important to protect our systems, why it's important to use static IP addresses, why it's important to have a DNS set within our terminal, or endpoints, excuse me. All of that plays into the necessary part of security. And once again, don't use this in a real life scenario. Keep it in your virtual setting. We don't want anybody going to jail. We definitely don't want to be going against the Computer Fraud and Abuse Act. All right. With that said, I hope that you learned something. If you did, please like, subscribe, and hit that little alert button. We will see you next time. Have a good one.